Hi, we're going to be going over how to prepare the tweets for our text analytics project. And so what I'm going to be doing, I'm going to take all of the major candidates from a few weeks ago, because that's when I pulled all the tweets. This was from before spring break. A lot of the candidates have dropped out since then, but we'll go ahead and just show the techniques as is. That way, if you chose one of these candidates, you can just kind of see how things go. And now, what I do when you do text analytics, especially the data prep phase, there's a lot of ways you can do it that's correct. The order of your choices matters. You'll get different results depending on what you do. You'll go around, play through with what's going on, and see what you feel like is the best choice. So here's my code in an R document, R Markdown document. First thing I do, I set my working directory. Then I tell R which files I want to have pulled, and then I go through and I load all of them from using the lapply function. And so I pulled all of these tweets. This is from the stuff that we've talked about previously in class using the code that's posted on Canvas. And I'm reading CSV on all of these files at the same time, and then I go through, and so this generates a list. This is list apply. That's why there's an L there. And as is, there's no names to it. I go ahead and I put names on there, and I name them exactly these values. That way I know which person it corresponds to. Now let's go ahead and clean up the author's names. So it's possible that the author changed their name throughout their Twitter history. So I went ahead and just put it onto one consistent format for each one. So this one, what I'm doing here, notice I've got just one there. I'm creating a table. I'm sorting the table so that it goes from most frequent to least frequent. That's what decreasing equals true does. And then I use the names function just to grab the first name. So if they changed their name throughout their Twitter history, then it's not going to change anything. I've got one common one for each of the authors. And I go ahead and I create a target column for each of the candidates. And then I reduce the entire data set to just two columns. I've got my text column and I've got the candidate's name, and that's all I want. I'm not going to worry about the other stuff. I'm not going to worry about retweeting or any of that stuff. I'm just taking the text, taking who wrote it, and that's all I've got in my data set at this point. Now, realize that I've got a list where there's a data set for each individual candidate. Well, they're all separated on different elements of the list. What this line does, this puts them all together into one data frame, which is good. That's what we want. All right, so now let's go ahead and let's start actually preparing the text. What this line does, this line converts all of the letters to lowercase, so I have a common format. And something that you'll notice throughout this, I'm specifying which package I use almost every single time. I'm not actually loading my packages. I don't want package confusion, so I'm using the double colon operator to be able to specify which package I want on each step. There are multiple functions that will convert like to lowercase. In general, the stringer package is a good choice, so I'm using that one on most of these times. Honestly, at work, I usually use just base R functions because those are the ones I learned first. But I want to teach you the better way to go, so I'm using a stringer package most of the time here. All right, now let's go through and let's remove like special things in tweets, like hashtags, email addresses, website URLs, stuff like that. So I go through, I remove URLs in the Twitter format, and I use the URL in the general format. Now, the QDAP regular expressions package has a ton of special removal functions for you. If you're going to get serious about text analytics, you're going to definitely want to check out this package. It cleans up a lot of stuff for us, makes it a lot easier. Here we're getting rid of hashtags. And here we're getting rid of where other people were tagged. Here we're getting rid of emoticons. Get rid of emails. And now there's some special features to Twitter that appear between the inequality symbols, and I just want to get rid of those because those are not useful for our text analytics. This symbol appears frequently in my data set, in my pool, and that's not useful for my purpose, so I'm getting rid of it. Once again, another special character that's appearing, and you'll notice that that looks like, apostrophe when I go ahead and print it. So I replace it with an apostrophe so that later on when I replace my contractions, I have the punctuation I need. Now I go ahead and I replace international symbols with their English counterpart. Now I'm going to go through and I'm going to replace a few symbols with words. So here I'm replacing the plus sign with the word plus. Now notice I have a double slash in front of the plus sign. So this is saying, this tells R that I want exactly plus symbol. I don't interpret it as being a plus sign to add two numbers together. Interpret it as the character plus sign. Replace an equal sign with the word equals. Replace plus minus with plus minus, and then we've got an ASCII character, replacing that, or actually just getting rid of it. Replace a 1/4 with a quarter, a half with a half, funny looking 3 with 3. Now all these weird symbols are in my data, and that's why I'm getting rid of them. I went through and I checked out my data enough that I know all the weird things that's in there. To find out what was in there, I use a string split statement and then use the unique state unlist and then unique to show what was all the individual characters. And I found the individual characters and I removed them because I don't want them to be there. In R, there's no line underneath, and I interpret that as being a degree symbol. Not 100% sure. And now I'm replacing contractions. Now the QDAP function, the QDAP package has functions that will do this automatically and manually, but on my machine I had problems with Java and QDAP, so I'm doing it manually. The QDAP regular expressions package has special functions that will remove like phone numbers and zip codes for us, time, dates, stuff like that. And for my purpose, I feel like that's not going to be informative, so I went ahead and got rid of it. It might be important to keep that. So like specifically if someone is tweeting about like Christmas, or if they're tweeting about the election day, those are dates that I might want to keep in there. But for me, I went ahead and got rid of them. I felt like they weren't enough utility for what I was doing. All right, now a lot of what I just did is redundant to what I'm going to do. All right, there's something called regular expressions. You notice how I've got this going here. I've got the brackets and I've got the colons, then I have punctuation, then I have digits. What this is going to do, this part here is telling R to take any punctuation symbol and replace it with a space. This is telling R to take any number and replace it with a space. And down here, this is telling R to get anything that is not like a letter, anything that is like it's a little bit more specific than that, but I'm basically getting rid of everything that's not a number, not a letter on this statement, and replacing it with a space. Now, why do I always replace with a space? I replace with a space because that makes sure that I have a gap between things that I want to have a gap between. From my experience, that's the better way to go. All right, so now, remember from our previous video, we talked about something called stop words. Stop words are words that are not informative for what we're doing. So, for example, for, and, nor, but, or, yet, so. If I see those words, I don't know what's going on. If I was to see something like nail, hammer, wood, I'm probably talking about something like carpentry or some kind of building. You know, in that second example, just knowing those words, I know the topic of information. I can make an inference about what the document is about. Stop words are words that don't really tell me a whole lot, and they're really used for grammatical function, not for being informative to what's going on by themselves. What we want words that are informative by themselves in general. All right, so I went through and I used 3 different collection of stop words. So we've got the group from kind, the group from smart and English, and these are from the TM package. Here, this is from the QDAPS dictionary. They've got top 25 words, top 100 words, top 200 words, and I think there's a few more in there, but I just want to go through and make sure you know all your different options. If I remember correctly, this one has the most, then this one, and then this. It's in the previous video if I'm wrong. And so by removing more stop words, you're being more aggressive about getting those unformative words out, but you can also overshoot. So when you're doing a real project, you want to go through and you want to make sure that all the words you're removing are words you want to remove before you remove them. Now, you'll notice that I went through and I replaced almost everything that I took out with a space. And now if I was to go through and look at my actual tweets, what's going to end up happening is I've got a ton of extra white space in there. I've got spaces in there that I don't actually want. What this is going to do, this is going to get rid of spaces that are unnecessary. This //s plus. All right, so what is it? //s is individual spaces. // plus is more than one space. And so what I'm going to do whenever I have more than one space, I'm going to replace it with one space. Previously, I went through and I replaced all my dollar symbols with the word dollars, and I realized after working through that there are too many dollar symbols in the tweets for them to be useful. The word dollars was just too frequent when I got my output. I thought, you know what, this is the wrong way to go, so I went ahead and got rid of it. I left the code in case you're interested. All right, now this next step is a big one. This is a very important aspect to text analytics. All right, so what we're going to do, we're going to take words that have common roots, common stems. We're going to reduce the words down to their stems, and then we're going to replace the stems with a common version of all the words that were replaced. All right, so here, what I'm doing is I'm taking all the words I've got, and I'm making a list of all the distinct words I have. And that's my dictionary. And what I'm going to do, what this does, this reduces the words to their stem, and this code here takes the reduced versions and completes the words using the dictionary that I built up here. All right, for this step takes the longest of all of the code that I've got going. By default, it takes the most frequent most frequent word that connects to a stem is the word that is used for stem completion. You can set it to random, first, or last also. Most prevalent is the one that is by far the most informative for the reader, but that also takes the most time. Going with random or first, I found is probably the faster way to go, but it's not a huge improvement. I'm going to skip it here, and we're going to work with the stems of the words just so that it's faster and easier for me to get through this project. Now, something about what I'm doing, I am manually manipulating the character strings themselves directly. You'll notice that, for those of you who have worked with text analytics before, you'll notice I have not put things in a corpus yet. I wanted to first show you how to do this without putting it in corpus format because I could not find any examples online for doing that. I wanted to show you this technique in case you're in a situation where creating a corpus was an unnecessary step down the line. Yeah, if it just isn't worth the trouble of converting, then manipulating, then converting back, which I find myself in that situation from time to time. And so I'm just going through and reformatting things. And I go ahead and I save my data set, and I go ahead and then I reload it, just because when I was writing my code, I was only working on chunks of code at a time, and this could be skipped right here. Now here I'm converting to a corpus. So something you'll notice, I have the vector corpus function, and it's receiving a vector source on the tweets. So this is in vector format. For the TM package, the vector needs to be passed to the vector source function, and then the vector source needs to be passed to the function that converts it to a corpus. Something that you need to do if you're going to be working with the TM package, which is by far the most common way to do this stuff in R. So now what we're going to do, we're going to create a document term matrix. All right, this is going to be an integer matrix that counts the number of times in each individual tweet a particular stemmed word was used in that tweet. And now if you look at this, there's going to be a ton of zeros in there, and most of the numbers are going to be relatively small. That's all right. So what we're going to do is there are sometimes that like a word only appears in like one tweet out of all of the thousands that I've got. Well, it only appears in a few tweets. It's not going to be useful from a statistics point of view. So when I do a document term matrix, I'm converting all of the words into like dummy variables, but counted dummy variables. And in that situation, I'm going to have a lot of zeros. And I'm going to have lots and lots and lots of zeros in there. And just like when I have dummy variables, if it's sparse, if there's only a few non-zero entries, it's not useful. So I went ahead and I'm going to remove the sparse terms. The sparse terms are the ones with a lot of zeros. So if it has 99.5% zeros, I'm getting rid of it. Now, if I reduce this number, I'll have fewer words left in my document term matrix. The fewer words I have, the faster things will process down the road, but I'm also losing words. You have to make a choice. You have to make a decision. This is kind of, I'm not losing very many by going with this. And here what I'm doing, I'm creating the matrix M, which is just a standard regular matrix in R for that corresponds to my document term matrix. Now, why did I do this? Because once I have a regular matrix, I can do anything and everything that R can do with a matrix. And now I'm cooking with gas. And you'll see that I've got, over 25,000 individual tweets, and I've got 502 words. All right, so I've got, from a statistics point of view, I have 502 predictor variables to work with. That's a lot. That's a good number. And that's after removing sparse terms. There were more terms previously before I removed the sparse ones. All right, now let's go ahead and let's make a word cloud, and let's look at what are the most common words that come out. So here, what I'm going to do, I'm going to create a data frame. I'm going to take the column names from M. I'm going to take the sum of the frequencies, and I'm going to make a data frame. So frequency is how frequently it comes up in all the tweets. Now, when I do this, if you were to say fight, fight, fight in one tweet, then fight gets counted 3 times. This is not the number of times a word appears in a tweet. This is the number of times that the word appears anywhere, someplace, some shape, some form. So here, in a way, we have a double count going on. There's something you need to think about. Is this the best way to go? If you have a lot of fight, fight, fight type sentences going on in your tweets, then you're like, maybe I just want to count the number of times a word appears in tweets instead of how number of times that it's used. All right, so let's go ahead and let's take a look at the most frequent one. You'll notice that I sorted the term frequency data frame by frequency, and I use the tail just to grab the bottom. So the 6 most common are President, Trump, American, AMP, country, and fight. Those are 6 most frequent terms. Now let's go ahead and make a word cloud. Now to make this easier to look at, I limited it only to 25 words. And we can see our top 6 are popping up right here. Now this is across all tweets, across all candidates. Now some of the functions in the TM package only want term document matrices, and so to create a term document matrix, I just use the term document matrix instead of document term matrix. What's the difference? All right, remember, when I talk about matrices, we always say rows before columns, rows before columns. If I say document term matrix, documents correspond to rows, terms correspond to columns. If I'm doing term document matrix, the terms correspond to the rows, the documents correspond to the columns. And then I go ahead and I remove the sparse terms. Now, there's a faster way to perform this. I could have just converted between the two. The TM package has that. I'm choosing to do it this way just so that you know about both of the functions. Now here what I want to do, I'm going to take all of like Donald Trump's tweets, put them into one big master tweet. I'm going to take all of Bernie's tweets, put them all into one big tweet. All of Elizabeth Warren's tweets, put them in one big tweet. And I'm using the aggregate function to do that with the paste. All right, so now let's go through and let's create some word clouds for each of the authors. And you'll notice I've reduced down the number of words just to make this a little bit easier to see. Let's zoom this out a little bit. Okay, unfortunately it got cut off here, but so here's the first candidate. Here's Bernie. We can see President Trump. So his most common words are Senate, Trump, Republican job, impeach, President Schiff. Oh, that's interesting. Democrat, AMP, and American. And remember, these are the stemmed words. Elizabeth Warren, she's no longer in the campaign at this point, but work, you president, care, family, structure, fight, plan, Trump, country, American. Fight is a big one for her in her tweets. Former VP. And if you look at his, if we had just a few more words, we'd see like VP, vice would also come up. You can see that he's referring to being a vice president in his tweets. Mayor from South Bend. American is coming up big. Veteran comes up with his stuff if we had more words appearing. Not surprisingly, this candidate has climate as one of his top ones in crisis. Tulsi Gabbard coming from Hawaii. Aloha is a nice and interesting one coming from her. So for your predictive model, if you had Tulsi Gabbard in there and you see the word aloha, you probably know it's not Donald Trump. Now let's go ahead and let's do some clustering just to see, how are these candidates similar to each other or different? And here I only did Euclidean and Manhattan distances. Only did Ward D and single linkage just to make it fast, make it easy on me. Really did not print up very well, but we can see that these candidates look like they group together well. Then kind of we got Joe Biden and Bernie and Elizabeth Warren are coming together. For some reason, it printed this upside down. That is interesting. It didn't do that on my screen when I ran the code. But hey, learn something new every day. And that's with Ward D. And here, using single linkage, we can see that Elizabeth Warren is the one that's kind of like by herself, which is interesting. and we can see that Donald Trump is like the second outlier-ish one of the group. These plots look a lot better on the RStudio screen than how they're appearing here. All right, now here we've got Ward D going on, and it looks a little bit more informative. We can see President Trump kind of hanging out by himself, which is a little bit more intuitive on how it should be. All right, so now let's go ahead and let's create word clouds with those who have like more similar tweets going on, or different. I can't remember which one it is, but oh, it didn't print. Darn it. Well, if you run this code, it will give you the word clouds. Yeah, I completely skipped it. Darn it. All right, so now we can find associations. So we can, what we can do, we can find words that are associated with president and Trump, because those were very common words when we looked previously. And the ones that are associated are Obama, run, unit, impeach, American Foreign Office, state, Constitution, and corruption. And this is when we're talking about the tweets that have the word president in them. That's kind of interesting. So here, what this function does, it went through, it took all the tweets that have the word president in it, and then finds all the words that are in those tweets, and we're looking for words that are highly associated with the word president. Over here, we're taking all the words that are associated with Trump. So it's looking only at the tweets that have Trump in it. So let's go down. Let's see what that looks like. All right, so the first one is Donald. That's not surprising. Then defeat. So it looks like things are competitive, because we got defeat, then beat, then so the Trump administration, then Iran. Now finally we got one that's actually about policy. Corruption, immigration, impeach, November, cut, danger, policies, racist, tax, undermine, white, one, foreign, lie, and trade. So it's kind of interesting to look through. You can kind of see, you look at it and you can guess, which side of the aisle each of these terms are really coming from. And now I wanted to go ahead and take a look at which ones had Obama in them. And I found this one to be really interesting, is that the number one person tweeting the term Obama is, well, his former vice president. Oh, that's not surprising. But then his successor is the one who second most frequently. And, so both of them have tweeted more than all the others the term Obama. I think that's kind of interesting that President Trump has tweeted that often about someone who's no longer in office. All right, so now let's go ahead and let's make a pyramid plot and take a look at how the two candidates that are still going, or still leading, I guess, compare to each other. And now this takes a little bit of data prep to get this into the right formats. But so here we can compare the two, and this looks better when you print this on the RGUI or RStudio. But we can see impeach is a major word, and President Trump is saying it a lot more. Democrat, major word, Trump is saying it more. AMP, Trump is saying it more than him. Now when we say the term Trump, Biden's saying it more often. Donald Biden's saying it more often. Biden's talking about both of them more than either one is. A nation, Biden's saying that more. So, we can go through and we can see how do they compare and contrast with each other. I think this is really interesting to see how these major terms are, being used by the different candidates very differently. And now I go ahead and I build a random forest with the author of the tweets being the target variable, and then the individual terms that we've got here. So the words that are left over after I remove the sparse terms are all I've got. So I've got 502 predictors. This is a lot. So let's go through and let's see what we've got. So 500 trees, and I've got about 48% accuracy going. Now remember, I've got all those different candidates to work with. The more candidates you have, the more like classification levels you have for your target variable, the harder it is to get a solid accuracy percentage on there, because there's so many more ways to make an error. If I have two different candidates, that's two levels, so there's only one way to make a mistake. Now if I have 3 candidates in there, there are 2 different ways to make a mistake. If I have 4 candidates, there are 3 ways to make a mistake. And you can see by having more candidates in there, I have more risk of making a mistake each time my random forest decides if it's going to be Donald Trump or Bernie or Biden or whomever. So when you go through and you build your model, you're not going to have, I hope your accuracy beats mine, because you got much lower hanging fruit to work with. Now, something you can do if you're struggling with the computation time of this project, what you can do, you can remove your stop words right out the gate from the beginning and do your data prep. I would recommend removing your stop words again later down the line. Also, if you remove more sparse terms, you're going to have fewer predictor variables. It will take less time to work on. I want you to actually stem complete your documents. I want you to do the completion phase. I didn't do it here because I've got so many terms in here and so many tweets that it was just taking too long on my wimpy laptop. But I want you to go ahead and do that just to see how that works out. And that's all I've got. Please let me know if you need any help with anything. I hope you find this fun. I always enjoy text analytics. Something I personally like to do with text analytics is if I need to read a book but I don't feel like reading it, I try to get like the text downloaded. I'll pass it through like all the techniques I've shown you tonight and sentiment analysis and some other stuff. And then what I'll do, I'll just look at those analytics, and that gives me kind of like a big idea of what's going on. And then I'll read like the summary on Wikipedia, and so that way I've got a good idea of what's going on without having to actually spend the time of reading an entire book. I know it's lazy, it's terrible that someone with a PhD is admitting to this, but I find it's just a lot faster and it's more interesting in my mind because of my background and my interests. Take care. Please stay healthy.